India, home to over 1.2 billion people. We are now in a phase of rapid development. There are numerous factors that are hurdles in the course of becoming one. The biggest one we believe is crime.
Crime is a continuous challenge for police and society.
There are two ways to deal with crime: ethics and technology. We decided to use the latter to efficiently and economically curb theft and burglary. We present to you the Smart Key.
The main idea of our project is to provide a security feature that is hard to crack. Even though biometric based devices like fingerprint detectors are secure, they aren't impervious to fingerprint duplication. The Smart Key is a portable plug-and activate device that provides two layers of security. One is through fingerprint recognition and the other is through a password that can only be felt. This is done by using a push button and a cell phone vibrator. As the push button is pressed down, vibrations of random durations are generated. Each vibration is a count and the number of counts is your password. We can increase the security level by having a multi-digit password. The key advantage of this is being its ability to be accommodated in wide range of applications like home security to bank security.
A security system must be operating round the clock. This is vital as developing countries face frequent power cuts. We want the Smart Key to reach the middle class sector, which constitutes more than 50 million of India's total population. For the common man, an inverter which costs at least 15,000 rupees is luxury. So we decided to independently power the Smart Key. We wanted to make a low-cost DC UPS which is compact and would support long hours and days of power failure. The DC UPS what we have designed is completely based on linear integrated circuits and analog electronics.
This is a bridge rectifier with a C filter followed by a switching voltage regulator. We used Texas Instruments TL2575 ADJ as it offers a high efficiency of 88%. For the backup supply, we used a 12-volt lead acid battery with a capacity of 1.3 ampere hour. This would be a good power housing, keeping in mind the low current draw by our load. We made a battery monitor and charger using Texas Instruments LM358N op-amp in an inverting trigger configuration. This is Texas Instruments LM358N based power supply selector that chooses the supply between mains and backup. This embedded UPS can power a wide variety of ICs as it has points for 3.3 volt, 5 volt and adjustable 0 to 12 volts, for which we use Texas Instruments TL257533IN, 05IN and ADJ respectively.
I have integrated the UPS and the Smart Key. This is the whole setup of our project. I am powering the Smart Key by using 3.3 voltage from the UPS. I will insert the Smart Key into the receiver. The white LED indicates proper connection. As explained earlier, we have two layers of security. I have connected red LED in parallel with the vibrator so that random timing between vibrations can be better visualized. The default password is 5 counts. Now I will press and hold the push button until 5 vibrations. 1, 2, 3, 4, 5. I will give my fingerprint. Finally, the green LED indicates valid user. What would happen if I make a mistake? Say I remove my finger so soon I get a red light from the system. I have had 2 wrong attempts. The system gives me at most 3 attempts to get it right. Otherwise, what happens? An alarm is triggered which ceases only if an authorized person checks in. Being a valid user, I have 3 options. I can register a new user, delete an existing user, or change the password. This is possible through this control board. We can vary the password to any value. For simplicity, I will set the password to 3 counts. For that, I am supposed to authenticate first. Give the valid fingerprint. Yeah, this is the valid one. Now press and hold the set button to get required vibrations, which is my password. Now I have set it into 3. Now let me check the password. 3. Give a valid fingerprint. Yeah. Now the operation is proper.
All the while, the smart key has been an inspiration to us. We want to present it in a pleasing, affordable and portable form. We want the smart key to take a form that can make its way to every one of the hundreds of houses you can see behind me. We modeled the case in AutoCAD and got the individual pieces laser cut. It is our pleasure to give you a real-life implementation of the system. So we are geared up for the demo, and let me introduce the departments of our system to you. This is your companion, the smart key. This is the key receiver in its acrylic case. And over there, we have the hub for the UPS, the MSP 430 G2553 in the launchpad with the shield, and the driver boards. We named the hub Home Smart Home. We have provided a provision for removing the battery in a hassle-free way. We can see a bunch of cables running between the key receiver and the Home Smart Home hub for communication. However, the two parts that make this implementable right away are the siren and a DC electromagnetic door lock. These are pretty inexpensive, and most ATMs and banks use these EM locks. So the system can be integrated into them right away. Now that we are all set, it's time for action. Shashanka is the house owner.
Hi.
Let's see how he gets in. The door is locked. He inserts the smart key. He clears the count. Validates his fingerprint. Voila, the door opened. We have the intruder Sumukha Chandra here. Hello, Mr. T. He looks like a smart one. He tries his smart key. Alright, he's down 2 attempts. And off he runs. Here comes the house owner Shashanka. He validates his fingerprint and the buzzer stops. Looks like Shashanka wants to register Sumukha. He inserts his smart key. Validates himself. And the stage is all set for Sumukha to register himself. He presses the register button, scans his fingerprint into the database, and now he's an authorized user. Let us see him try validating. Shashanka shares the count with Sumukha. He gets the count right. It works. We have Sumukha Chandra here who wants to delete himself. He inserts the smart key. Validates himself. He now presses the delete button and uses his fingerprint, which he wants to remove from the database. He's not deleted. He verifies. and is no longer an authorized user. This is our first time competing in Texas Instruments India Analog Design Contest. The journey looks so beautiful when we look back all the way to the day when we first found this on the TI India Facebook page. A heartfelt thanks to Dr. C.P. Ravikumar and Sagar Jinaja of Texas Instruments India,
Our XOD SP Bhanuprasad sir,
Our mentor, Assistant Professor Subodh Kumar Panda,
and our College-BNM Institute of Technology for their support.
we owe the Smart Keys existence to the TI Launchpad and the MSP430 series of microcontrollers, which were so easy to program and debug on CC Studio. We just want to say one thing. Thank you, Texas Instruments India!